Okay. Are you ready to start?
Yep.
Okay. Hi, my name is Melody, and I'm going to be hosting this session. Before we start, I think Dr. Meng wanted to share a few words with us.
Oh, well. Okay, thank you. Thank you, Melody. Right, and thank you, everyone. Good morning, everyone. Yeah, I'm really glad to welcome all of you to this special event. As the person who started this event, I want to give everyone a big hello. And today we have a very special group speakers here. FTC team 8565 Technic Bots. So this is a team's name. They represented the United States not once, but twice in the World Cup competition in 2021 and 2022, respectively. We also have some amazing people here, including head coach Dr. Fan Wang and Mr. Pavel Gu, and our talented key members of Byron Lee, Ryan Shu, and Melody Hu. Welcome. Throughout this event, we have planned an exciting evening focused on growth, innovation, and creating creations. We have brought together coaches, young tech experts, thought leaders, and innovators who will share their insights and experience. We hope this will spark interesting discussion and inspire new ideas. I want to encourage all of you, audience and speakers even, to get involved and share your thoughts and make the most of the knowledge and opportunities presented here today. Once again, I want to give you a warm welcome to all of you. Thank you for joining us in this amazing journey of exploration and discovery. I hope you have a productive and enriching experience through the evening. Thank you.
Thank you, Dr. Meng. Okay, so we're going to go ahead and get started. Okay. Can you guys see my screen?
Yes.
Okay. Okay, so I'm going to start off by going over a general agenda. So we're going to start with an introduction to Team USA and the Technic Bots Robotics team. And then we're going to have a brief speech from Coach Gu, and then a brief speech from Dr. Wang. And then Byron he's on Team USA and Technic Bots will do a presentation over the carbon capture innovation project. And then we'll have a short Q&A over that. And then Ryan Shi will do a presentation over advanced control topics in robotics. And then we'll also have a short Q&A on his project. And then to end it off, we'll have a panel discussion with me, Byron, and Ryan about just robotics in general. Okay. Oh, I think this is, sorry. Okay, so my name is Melody, and I recently graduated from Team 8565 Technic Bots. On the team, I was the team captain, and I was responsible for a lot of the business and outreach part of the team. I spent 11 years in FIRST Robotics, and I also recently graduated from the Hockaday School in Dallas, Texas. And this fall, I'll be studying at UC Berkeley under the MET program, and I'll be double majoring in business and EECS. Okay. And then before I do a team introduction, does Coach Gu want to say a few things? Coach Gu.
Okay, can you hear me?
Yes.
Okay, better. So thank you, Melody. So thank you, Dr. Meng Yu, to give us and our team this chance to presenting here. So I'm just gonna say a few words here. So when initially I was getting contacted by Dr. Meng, I was hesitating because I was about what took us up to robotics. And then after a few discussion, and he was actually educating me like it's not about just robotics, it's about our awesome young men and boys and girls in our team. How can we getting through solving different STEAM related problems, and how they're going to grow themselves on getting different capabilities and lessons learned from this procedure. So then I realized this is a great opportunity for them to show up here to like share their stories, share their experience, not only about the projects, but the story behind how is he getting there. So that's what I learned from Dr. Mo's camp, and I really appreciate this kind of opportunity. And I'm gonna pass it over really quick to maybe Melody or Dr. Wang Fang to give more briefing insights on this. Thank you.
Yeah, if Coach wants to speak, Coach Fang.
Hi, hello everyone. I'm the coach for 8565 for the last for 14 years. And last year we passed down to Coach Gu as a head coach of 8565. So I'm coaching the team since 15 years ago. And last year we were Inspire Award winner at the World Championship. So look at the journey back. I feel the two things we have been working with kids, with team members. One is take an initiative and stick to it. Be patient, be resistance of any failure there. So that's one big part. Another part is in my team, we always focus both technical side and the business side. So as Melody mentioned, she's going to attend MET program. She's actually second graduate from 8565 going to MET program. We also have a graduate going to European M&T. So that's just where we're sending our graduates from this team going on. And the things they learned in the team actually help them to build up in the next phase. We also have a graduate. He was actually a builder. So throughout the whole training, he was a builder, but he was admitted into UTCS. And within one term, he just admitted again into the touring program. So he has the goal and the initiative and the work on it. I think that's all we trained our team members from the Technibots, the journey here. And that's they carried towards the next chapter of their life, and I can see how that's applied to help them grow after the team. So that's what I want to share with you. And then later, during the panel discussion, if there's more specific questions, I can answer. Thank you.
Thank you. So now I'm going to give a brief introduction about Team 8565 Technicbots. So Technicbots is a first tech challenge team from Plano, Texas, and we founded the team in 2009. The team has grown consistently and started from 6 founding members, and now we are a 15-person team. Our team does a lot of various events to engage students with FIRST programs and promote STEM throughout the community while also building and creating and competing these robots. Some of our proudest accomplishments include, like Coach mentioned before, winning the Inspire Award at the World Championships. The Inspire Award is the most prestigious award in the FIRST Tech Challenge. We also won the Inspire Award several times in the region. And because we won the World Championships in 2022, we were inducted into the Hall of Fame. We were also selected as Team USA in both 2021 and 2022 to compete in the FIRST Global Challenge. The FIRST Global Challenge is an Olympic-style robotics competition with one team representing each country, and there was about 180 nations competing. So yeah, next I'm going to introduce Byron, who is going to do a presentation on something we worked on for the FIRST Global Challenge. So Byron is going to be giving a presentation on Team USA's innovation project submitted at the 2022 First Global Challenge in Geneva, Switzerland. The project utilized machine learning in the IoT domain to propose a framework in large-scale sensor networks for CO2 detection and verified deployments globally in the US and India. The project has been highly recognized by First's founder, Dean Kamen, and recommended to a massive number of executives from global enterprises and organizations. Byron is graduating from Team 8565 TechnicBots, and he will be studying computer science at Yale University in the fall. So Byron.
Hi, everybody. Let me share my screen real quick and let's get started on the presentation. Slideshow. Okay, so Melody has already given me a nice introduction. Can you all see my screen, by the way?
Yes.
All right, perfect. All right, so Melody has already given me a nice introduction, so I won't go on that long, but as a brief introduction to sort of the team and stuff in general, I know Melody has already listed out a bunch of our accomplishments, but I just want to talk a little about the structure of our team, because I think that's something very important, and the way we work together. I'll be talking about that a lot throughout my presentation, because I think that's the main takeaway from our project. It's not really like all the cool technical stuff we did, although we did a lot of that. It's more about how we all contributed as part of a team to make this final thing. So one of the core features of our team is that we have a lot of people from different age ranges. So Melody talked about, she introduced herself and she introduced me. We're both seniors right now, which means we're going to graduate to college next year. But besides that, we have people like Ryan, which are currently high school freshmen or sophomore or juniors. And so they have a lot more time on the team. And so what we do is we recruit people every single year, and we have a very thought out mentoring pipeline where all the seniors help out and try to kind of train and have the younger members shadow us, so that they're always learning. Everybody's learning and working together from each other. So this is the team structure. A little graphic here. You can see me, you can see Melody, you can see Ryan, and you can see all the rest of the team. So after that, let me introduce First Global a little bit. You might have heard Dr. Meng or Melody mention the World Cup, First Global, a lot of stuff. But let me just explain from the beginning. So First Tech Challenge, which is the event that we usually compete in, is based primarily around the US. Of course, there's First Tech Challenge countries, teams from all over, but most of the teams are from the US and we compete in the US. First Global Challenge is different. It's a separate competition that only one team from each country is invited into. And so in 2022, the year we're going to be talking about, we were the sole team from the US, but we had teams from Armenia, Azerbaijan, Morocco, we had teams from Switzerland, and basically from all over, one team from each country. So it's a really amazing event, and we're really glad to have the chance to represent the US twice already. So in every First Global Challenge, what the team country does is they're supposed to prepare a solution. And a solution is basically their own little project aimed at solving some part of the world's problems, because that's what First wants us to do. They want to train problem solvers from the next generation up. So what we decided to do for our project was look at industrial emissions, because as you can see from all these graphs here, industry and pollution is a huge problem, especially in the US. The US is the world's second largest carbon emitter, and and as you know, like, our country is dominated by a lot of large tech companies that hold a lot of political power. And so often, even though we know they're emitting a lot of pollution, it's hard to get accurate carbon reporting. So that's what we decided to look at as Team USA, the sort of uniquely American problem, but also obviously carbon emissions affects the whole world. So that's feeding into both our role as Team USA and our role as First Global. So how we decided to tackle this problem was, first, we looked at meeting experts. So as you can see, we reached out and we talked to professors, professors from Cambridge. We talked to employees at the EPA, and we talked to even more professors to discuss a lot of the potential solutions towards the problem of emissions. So that's a little bit of the part I want to emphasize, which is how the process of FIRST is kind of different from what you would imagine. Like Coach Gu said, it's not just robots, right? It's a lot of interpersonal skills and speaking. So even though we, at the end, we built something, we use our robotic skills to build something. Before we even did that, we had to use our social skills to reach out to all these professors and important experts in the field and connect with them and learn from them. So that's a really important part. After meeting with these experts, we came up with a solution plan, which was to make a low-cost carbon sensor more intelligent through the use of artificial intelligence. So I'll give you a brief bit of background. So right now, if you search up carbon sensor on Amazon, you can find things that will tell you the level of carbon for around like $40, $50. It's not that expensive. However, once we talk to those experts I mentioned, we realize that when they're actually doing scientific studies, they're using high cost sensors that cost over $10,000 each one. And the reason why they have to use those is those are a lot more accurate. The ones you buy for cheap off Amazon are often very, very inaccurate. And so you can't really use them for scientific studies or the purposes we want. So our plan was, even though we're taking this low cost sensor that's sometimes inaccurate, we can use our coding skills and the power of artificial intelligence to maybe make it more intelligent so that it can compete with those high cost sensors. And now I'm going to explain how we did that. So this is the bill of materials for the project. As you can see, we use a circuit board called the SparkFun Red board, and we combine that with a miniature computer called the Raspberry Pi. The Pi is very famous. I'm sure a lot of you have heard of it before. And then we combine that with both a CO2 sensor and an air pressure sensor. So the CO2 sensor is one of the very cheap, low accuracy sensors I mentioned, but with the help of the air pressure sensor, which is sort of an additional reading on the area, we can combine those two values together to make the final CO2 reading more accurate. And then, as you can see, we use InfluxDB and Chronograph. These are both Python libraries to actually display the results of the sensors. So I want to highlight two things here that I think are kind of cool. And first is the sort of extensive planning. So as you can see, our team has a tradition of documenting everything extremely detailed. For example, like we have the entire bill of materials set out, and before we build every part of our robot, we actually use computer-aided design or CAD software to CAD out the entire thing first. So we do a lot of planning beforehand, and that's what allows us to sort of succeed on the first or second try, or have a well thought out material or plan before we actually start building. So that's something you can take into account. And another part is sort of the division of labor, because not everybody, so like certain people on our team know how to use the Raspberry Pi, certain people know how to use the different sensors. And so it's not a one-person job. Everybody is working together to build this thing. So for example, the Red board and the Raspberry Pi were put together by our builders and connected as sensors by our build team. But InfluxDB and Chronograph were obviously programming, and they were handled by our software team. So division of labor is very important here. I'm going to talk a little bit about the machine learning model. I won't go that much into details, but basically it uses a deep learning architecture known as LSTM, long short-term memory, to process this data about CO2 readings, temperature, humidity, air pressure, all the things we talked about in those sensors, and combine them together by using deep learning to find the final calibrated CO2 reading. So what you want to look at here is the graph. You can see the big green line is sort of far away from everything else. That's the original low-cost sensor. So as you can see, it fluctuates a lot and it's sort of inaccurate. But if you look at the blue line is actually the corrected version. And the yellow line is the expensive $8,000 carbon sensor we mentioned. So the yellow line is pretty close to perfect. And as you can see, the blue line, which is our corrected model, is much, much closer to the true value than the green line is, which means that our machine learning model actually worked. We actually were able to get a much more accurate carbon reading. So you can see the root mean square error terms. You don't need to know what that means, but basically it just tells you a numerical value for how much better it is. And we can see like it's better by a factor of 24.69. So it's very, very accurate. It's very good. So if you have learned about machine learning or deep learning before, you might know that to actually train these models that we talked about, the long short-term memory, the deep learning, you need a lot of data. And so we collected that data through a variety of means. So first, obviously, we went out and we used our own sensors to collect data for ourselves. So that was done in both like outside in our own back doors and in those university labs because we needed the readings from those very expensive accurate carbon sensors. So we went out after we built the Arduino and we collected data from over there. But the much more interesting part was that we actually collected some data from India too. So, and the reason why this happened was because one of our team members, Hrithik, has been coaching and mentoring a school from a school of Indian boys for a long while as just part of our regular season, our regular outreach efforts. So Hrithik has been teaching this Himalayan English school for a long, long time. And so when we managed to build these sensors, we built another copy and we were able to contact the school of kids that we were helping and send out the sensors to them. And so we were able to not only collect data from our own hometown of Plano, but we were able to get some valuable data from India. And so obviously Indian temperature patterns, emission patterns are different. So it helps us get a truly worldwide sense of what the carbon levels are like and how they correspond to like different atmospheric results because different places will have different relationships between the two. So I think that's really cool. And again, it really emphasizes how robotics is not a one-person thing. It's really a team effort and it's made out of many different components. So we have hardware with the actual sensors and the processing computers, but then we have software with the AI model and we have outreach with our connections from India. And so without any of those things, the project would not be able to succeed. So again, that's just emphasizing the power of teamwork. And then here we are in some labs. These pictures are us in labs visiting various mentors and testing out our thing. I also want to talk about at FGC itself in Geneva, we managed to present to a lot of very important individuals. So we actually presented these graphs. I showed this graph myself to the founder of FIRST, Dean Kamen, as well as the US ambassador to Geneva. Her name was Miss Crocker. And so a lot of very important people got this presented to them and we hope they enjoyed. So again, that just shows the power, I think, of robotics and FIRST that after you've made the solution, you can spread a message out to even like the highest levels of society if you know how to get there and do all the right things and work very hard. And so we're very glad that we're able to spread this message and like show our solution to the world at large. Yeah, and then this is just a bit of plans. This is plans we had for the future when we finished FTC, but now we've already done most of them. So we've continued to cooperate with Professor Larry from UTD and continue to collect data to continue like improving our model. And also we partnered with the Indian Environmental Agency to use our tools for continuous data collection. So we're continuing our efforts in both the US and in India. So again, that just shows our attitude towards hard work and how we're always trying to improve even after the big competition is done. Yeah, the last thing I want to talk about is just like a bunch of the skills we learned. I already mentioned a lot of them, but technical skills like AI modeling, we learned a bunch about deep learning and architecture tuning from just collecting all the data and making the model. And we learned about hardware, integrating all the circuits together and making sure that it all fits in this one nice little box. It looks good and it works well without having to connect all the wires everywhere. That's very important. And in software, this is more of a general thing, not learned from the project, but Ryan's going to talk about control theory later and other advanced techniques. And that's something else you learn from robotics. But besides specific skills, we also have soft skills. So as I mentioned before, when we reached out to all those experts or when we presented to important people like the US ambassador or first founder Dean Kamen, we also learned a lot of communication and presentation skills. So that's really the part I want to talk about. Like Coach Gu said, it's not just about robots. It's not just about the things you build. It's really about the skills you learn from them and how you tell your story. So that's just as important as maybe the harder technical skills that are more obvious, I guess. Yeah. Yeah, and then I talked about most of this already, but I think we made a pretty big impact. We talked to the US ambassador as well as Dean Kamen, and yeah, further efforts in outreach. So besides this whole FTC event, besides our plans in India, we're also always trying to make sure we spread the word of FIRST and STEM in general to as many people as we can. So as part of robotics, I regularly mentor a lot of kids from the Boys and Girls Club, which is this after school daycare. And we also mentor a lot of other FTC teams that are perhaps like newer to the field than us or just need a bit of help. We're always looking to help out other teams and other members. So again, that's just a big part of FIRST. And that's why I think it's so special is this attitude of outreach, this attitude of always trying to help out. And so we're not just learning, again, it's not just the technical skills, it's the outreach, the word that you spread, and like the social skills you learn that are really important. So you can see we have some pictures here with some kids we mentored, as well as a message from our senator that we met as part of another mentoring event. Yeah, that's all the presentation I have prepared. But if you guys have any questions, feel free to ask in the chat or in the panel that I'll be doing with Melody and the other team members later. And yeah, that's about it. Thank you so much.
Thanks, Byron. Yeah, if anyone has any questions, they can add them in the chat right now. If not, we can save them for the panel later.
Yeah.
Okay. Okay. So next we will have Ryan. So Ryan is this current software team lead on TechnicBots, and he's a rising sophomore at Jasper High School. Ryan is going to be giving us a brief introduction on selected advanced control topics in robotic software with samples from Team 8565's award-winning robot from last season. The robot design was highly ranked in the World Championships and in the Texas State Championships for control software and excellent autonomous performance. So Ryan.
Yeah, so let me just do a second to share my screen. All right, can everyone see my screen?
Your voice is a little bit fuzzy.
Not sure if I can fix that. Is it better now?
Not much. The voice is larger. Do you have a microphone?
Yeah, I think I'm using microphone on my earbuds right now. See if this is better.
Oh yes, much better.
Okay. All right, so thank you, Melody, for the introduction. I am Ryan Xu, and I'm the software lead on Team 8565. Now, on the software team, we do lots of cool things, right, related to coding, but what we really like to do is focus on intelligent control of our robot. And something we're really proud of is how we're able to take college-level concepts like linear algebra, calculus, statistics, and apply them to a robot, and also learn so much about other valuable non-technical skills in the process. So today I'm going to be going over some of these features that we included in our world-class control award submission, a document that details pretty much everything that we do on the software team. So here's a little bit more about the First Tech Challenge season from last year. And it was called Power Play. And the main objective is pretty much you have these yellow poles on the field. They're called junctions. And what you want to do is you want to put cones on those junctions, and you get different points depending on how high the junction is. So you can see a robot on the left here. It's called Nebula. And hopefully this gives you a pretty good idea of how it works and how it's scoring on those poles. The first 30 seconds of the game is called the autonomous period. So you're not actually allowed to control the robot during the autonomous period. And this makes it really important for software to come in and employ all the sensors and control algorithms in order to automatically move the robot. However, we're also focusing on software outside of the autonomous period to assist the drivers in the remaining 2 minutes of the match. And I think I'm going to go ahead and play our state control award submission video, and I'll kind of stop and pause every now and then to give some of my advice. So something that I really think the autonomous mode is a great example of is how I and the rest of our team learns to work under great pressure thanks to robotics. So due to unforeseen circumstances, I would often only have 1 or 2 days before a very important competition to program the autonomous. And it's so important for both robot game and judging. And I learned how to stay calm and approach things in a really methodical way, prioritize what needs to be done first, and sometimes have to sacrifice some features that aren't as important. And these are skills that are really important to learn, and I was able to learn them from robotics. And you can see that the robot is scoring 6 cones here, which is actually the maximum amount that you can earn. And we're really proud of that. This video was recorded the night before the state competition, so you can imagine how relieved I was to finally get it working. And I think this also applies to the kind of hackathon related things that you guys are learning at this camp, where you have a very limited amount of time, maybe 2 days to deliver something.
Ryan, I think Dr. Bong raised the hand, means he got a
Yeah.
question or something. Dr. Bong, you're
Well,
mute.
yeah, I'm not. Well, let me see, lower. Okay, so I'm lower, right? I'm lower my hand. Okay, I clicked it by accident. Sorry about that.
Okay, we're collecting questions in the chat, and I think Melody is going to queue them in QA sections. But Ryan, sorry to interrupt, but you can continue, I guess.
Yeah, okay. So continue. So a little bit more about localization, which was just featured in this segment of the video here. Localization is pretty much how the robot knows where it is on the field. And this is really important because during the autonomous mode, we want to automatically drive the robot. And in order to do that, we have to check where the robot is. And we also want to use the robot's position to help the drivers during teleop. You'll see this a little bit later in the video. And most teams only localize during autonomous, because we take it 1 level higher though and localize during teleop as well. Normal localization methods don't really cut it for us. So you can see that in this visual on screen, which I can pull up in a little bit here. Yeah, so you can see that on screen, there are these 3 purple squares surrounding our robot. And these are called odometry wheels. They record how fast they're spinning, and we can calculate how fast the robot is moving. But they drift over time, and eventually your estimated position is going to be wrong. So you can see we added these distance sensors here represented by these lines, and they are correcting the error. And we use an extended Kalman filter to do this, which is pretty much the de facto standard for nonlinear state estimation in GPS and navigation. And as you saw earlier, this allows for very impressive results where we're able to localize within 1/4 of an inch throughout the entire 2 minutes and 30 seconds of the match. Okay, let's take another look at that clip here. So I want you guys to pay attention to the right side when the lift is going up. So if you notice, it really shakes a lot when it goes up, and this was really problematic for us. Meanwhile, look at the left side when it goes up. If you look at them side by side, you will notice that the right side is shaking a lot more than the left side. And that's because we're using linear quadratic regulator, or LQR, on the lift on the left side. And the reason why the LQR is a lot better is because the PID is kind of greedy and short-sighted. It's immediately trying to drive those motors to the set point. Meanwhile, our LQR is factoring things like limiting how much current, voltage we're using, how fast it's moving, and this allows it to be a lot less aggressive. And not only does this mean that it's less aggressive going up, but if you pay attention to how aggressively the PID slams down, the LQR is very smooth at the bottom. And we implemented this because we noticed that oftentimes when the PID lift would come down, it would slam down so hard that it would literally turn the robot off. And this was causing some huge problems, so we implemented the LQR. And something that's worth noting is that we don't just learn these kinds of graduate level control theory things with just one person programming everything. All of these projects, especially advanced ones like the LQR, are joint efforts. We have team members from different sub-teams within the software team that are all collaborating to achieve these kinds of large projects. So we actually had a software team member that was proposing to use the LQR in order to control the outtake. And we also had another team member that knew a little bit more about the math that's required to implement it. So we had these two team members plus another and multiple other software team members list out all the equations and write the code. So we went from idea to equations to code with different members working together at different steps of this pipeline so we could deliver this awesome result here. And another thing that I want to point out here is that the entire sequence of actions that you see, like when the robot goes up, when it comes out, that's all just one button. And that's another form of automation that we programmed into our teleop. We did this using a combination of delays and conditions. And this way, the drivers don't really have to worry about controlling these very subtle details, like how much am I going to rotate this? How much am I going to extend the slide? But this is also another example of how our team members really learn a lot about communication. So initially, we didn't have these features programmed into the robot. But because our driver team is constantly testing the robot, doing test runs, they're able to communicate with the software team on how we can improve driving features. So if they feel like something needs to be changed or can be improved or added, then they can let the software team know, and the software team can interpret their request and get it accomplished. Without this crucial communication, our robot performance wouldn't be near as well as it is today if we didn't have this kind of established pipeline between our driver team and our software team. So if I pause the video like right about here, and if you pay attention to the top right here, you'll notice that when the slide goes out, it actually pulls back afterwards. And the reason why it's doing this, even though it seems to have reached its target, is because it actually overshot it. It went beyond the position that it's supposed to, and it's having to pull back in order to reach what it wants to achieve. And this is bad because let's say the driver has positioned themselves so that when they extend the slide, it will perfectly reach the cone. Well, now it's going beyond the cone, so we're no longer going to be able to grab it. And this overshoot is highly problematic, and it really affects the drivers. So again, we had some communication between the driver team and the software team, and they said, hey, we want to fix this problem. And the software team solution was to use motion profiling. Motion profiling is another sort of long-sighted approach similar to the linear quadratic regulator, where we limit how far the slide can move at every single time step. And this gives it a really smooth curve. And you can see the amazing results on the bottom here, where there's absolutely no overshoot, and it immediately reaches the position there. So something I really want to emphasize here is how we use a set of heuristics to assign each cone a probability score. Most teams are just using the color of the object to determine if it's a cone. So for example, they'll see, oh, this blob in front of me is red, so I'll just assume that it's a cone. This video doesn't really go in depth on this, but behind the scenes, we're doing a lot of work in order to differentiate between the red cone and the red tape. For example, we will basically approximate the shape of the cone and determine the angle between the sides, the number of sides, the ratio of the height to the width, in order to determine things that are absolutely cones and things that absolutely are not cones. And this is an example of how on this team, we're always learning how to improve, and how we're also always trying to look for something better. And we're always improving through iterations, both hardware-wise and software-wise. Now, our first iteration of this cone auto aim pipeline was very rudimentary. We're just doing the color solution that I was explaining earlier. And it performed pretty poorly. So rather than settling for this mediocre performance level, we made some changes to improve the performance. And that was our second iteration of the cone pipeline. This is right here is not the second iteration. This is actually our sixth iteration of this pipeline, where after constantly trying to do better and better, we achieve this level where we can very easily tell where the cones are. And if we hadn't always had this drive to do better, then we wouldn't have been able to make it this far. And that's pretty much all that I have today. I can take any questions that anybody has, or I guess for a live panel, we can take those questions. And another thing that I want to mention is that if anyone is interested in joining either 8565 TechnicBots or one of the teams within our mentoring pipeline, we're actually hiring, and you can visit this link right here or scan the QR code if you are interested in applying. And without further ado, I think I'll turn it back to Melody for the next part of our seminar.
Thanks, Ryan. Yeah, so now we're going to start the panel discussion. Feel free to ask any questions about either of the projects that were mentioned, or any questions about robotics, Team USA, or the competition in general. If you have any questions for the coaches as well, you can also put them in the chat. So I think we already have a few. Ryan or Byron, you guys could take this one. How many years have you guys learned AI deep learning?
So for me, the first AI project I did was in sophomore year, but that was outside of robotics. And so I would say so I've been learning it for 3 years, I guess, but I don't think that's the most important. You don't need, usually for the AI stuff I did for the project, I learned it all there on the spot. So I don't think you need to do any additional studying on your own for AI related stuff, unless of course you want to. You should just focus on what you want and what you need for your project or whatever you want to do at that time.
Thanks, Byron. And then another question is, I know that Dr. Meng is here with the team. Is Dr. Meng the advisor for the team's innovation project? So Dr. Meng has been a great supporter for the team, but for the innovation project, that was led by our team members and then Dr. Fang and Coach Gu. Any advice to a rookie team? I can start with answering this question. I think advice for rookie team or anyone that's first joining robotics is to kind of explore different aspects of the team. So within the team, there's a lot of different sub teams and various projects and subjects that you can be a part of. And I think that kind of stepping out of your comfort zone and joining in on those is really beneficial, and you could find something that you're interested in or good at that you might not have tried before. Ryan or Byron, do you guys want to add anything?
Yeah, so I think in addition to what Melody said, something really important to focus on as a rookie team is kind of learning more than focusing on the results, because that's at its core and at the end of the day, that's what this program is about. It's about learning all sorts of skills, and you can see that all of our team members here today have presented so many different things that we have learned, and it's really a lot more than just robotics. It's not just learning about math and STEM, it's about learning business skills, how we can impact the community. And as a rookie team, those are the things that you want to focus on, and not, for example, making it to the world level competition.
Where do the kids learn more advanced control theory like LQR?
So for LQR, that was something that one of our teammates proposed. And what I think is really special about our team is that we don't just limit these kinds of things to just our software team, because this is a software concept. We have people from our hardware teams, from our business teams that are constantly making these kinds of suggestions. And they might have learned one of these things from somewhere else, but they're able to apply it to robotics. And someone from the hardware team, for example, can suggest using some sort of thing in our software. And another thing that we have is we're learning a lot of advanced skills from our mentors, which we're able to collect from throughout the community. And this is another aspect of that kind of more than robotics thing that we've been emphasizing throughout today's seminar, where we're reaching out to members of the community like professors and universities, and we're learning about these kinds of graduate level concepts from them and applying them to our robot. And as for how many sub-teams are in the software team, so our software team generally is just one team, and we don't really divide it further, but sometimes we'll divide it into 3 main groups. We have teleop, where we have the driver's control period, coding, we have the autonomous period, programming, and we have computer vision. And those are our main sub-teams that we would have.
Thank you, Ryan. How do you foster collaboration and teamwork within your robotics team?
So usually what we do for teamwork and collaboration is we make it very clear who's exactly doing what, so division of labor. And so in that way, we know like people aren't getting in each other's way. And another thing we do a lot is we do a lot of team bonding to make sure we actually like each other. So as a group, we play games, or like we go out and do things together. And so we just want to make sure like everyone on the team knows each other, are friends with each other. And I think the collaboration and the collaboration skills and the working together, all that will come with time, as long as your team like actually enjoys each other's company.
I want to add it here. In this part, so communication is very important in 2 aspects. One thing is communication earlier. So you have work, others depend on you. If you are not kind of reaching the milestone, the target date you set, you need to communicate earlier, not like last day. It's impacted the person who's next. So that's what always asking the team members to communicate earlier. Another one is, so our team is having meetings 50 weeks a year. So we only break for Christmas and the week after World Championship, when they are going for AP tests. And then, but the team members do have holidays, vacations going out, and competition. So they're going to miss the team meetings. So one protocol in 8565 is you need to provide your status the night before the team meeting. So even you are not there, the team work will continue. The rest of team members will make decision based on your action item status. So I think those that will help the whole team collaboration to get the project done. Thank you.
Thank you. How did you prepare for the competition and what strategies did you use to achieve success?
This is a very general question. So we prepared for competition by doing like basically everything. So we like worked on the robot, we prepared presentation scripts, we did all the outreach so we would have stuff to talk about in our presentation. I guess one thing I'd highlight as important is like that may not be obvious at first glance is a lot of stuff that happens at competition usually can't be foreseen or like it's kind of hard to foresee. So you want to make a lot of backups, and what our team has started doing is we have a backup list of like every single part for a robot because something always breaks a competition, and we have a list of things to go over before every single match. We call it the pit crew list. So like in the pits right before we are supposed to play a robot, we go over like every single part, make sure no parts loose, no parts like out of balance. So it's just a lot of preparation, thinking of what could go wrong and not just assuming that everything will go your way is very important.
Ryan, do you have anything you want to add?
Yeah, so something else that we really do for preparing for competition is we kind of go over every single thing in greater intensity in the weeks leading up to the competition than before. So, you know, sometimes the days before a world's meeting or before the world championship will be up till 1 a.m. to focus on all of these things. And this is really like the final drive to the competition that we have on our team in order to make sure that we're performing at the best we can.
Mhm. Okay, can you share some experience for like starting in FLL and like a rookie in FLL? I think I can answer this question. So I did FLL before. I think with FLL, it's important to kind of, I know we mentioned this before, but explore like various aspects of the team, especially before they get into FTC or high school robotics. And I think FLL is like a great foundation for FTC in terms of wanting to do robotics in the future. And I think it's also really important to kind of focus on that teamwork and collaboration aspect when they're younger. And that's also something that the program really emphasizes in FLL. Okay, another question is, what other extracurriculars do you have, such as sports, etc.? And how do you balance school, other activities, and robotics?
So I guess I can go. I definitely do quite a few extracurriculars outside of robotics. Like I play 2 instruments and I am on my school's debate team. And in order to balance these things, it's really about the most effective time management you can have. And one key aspect of this that I think I learned a lot about from robotics is prioritization, because you have so many things that you need to do that you're never going to be able to do every single thing in one day. And you have to know, okay, this is something important. I have a competition coming up, so I should dedicate more time to robotics, or I don't need to dedicate as much time right now. What's really important is I have a science fair competition coming up. So this prioritization system where you're not just trying to blindly work till 6 a.m. and do every single thing is really important if for balancing all these activities.
And adding on to what Ryan said, I think a lot of our team members have various activities outside of school, but robotics is also a really big priority in all of our lives, I would say. And I think that a lot of good communication with your team members. I think when you start to do robotics, you'll realize that a lot of the projects or tasks that you're assigned might depend on another team member, or another team member might depend on you. And I think being able to work together really effectively and efficiently is also beneficial in terms of time management with, you know, other aspects of your life. Okay, The next question, I saw that you've collected a lot of data from your sensor and the reference sensor. Did you also use a reference sensor to collect data at the same time when your sensor was presented?
I think Byron can help to answer this one.
Sorry, could you repeat the question, Melody?
Yes, I saw that you have collected a lot of data from your sensor and the reference sensor. Did you also use a reference sensor to collect data at the same time when your sensor was presented?
No, we didn't, because the reference sensor was like
Byron,
the-
I think he was asking for the training data sets, then yes. Because for training data, you have to take the reference data, right? So
I thought for the reference sensor, he was referring to like the big $8,000 sensor.
yeah, we gather those data for training. Yeah,
Yeah.
for getting those kind of big
Uh-huh.
data for training purpose. Yeah,
Yeah.
they have to process at the same time.
We did that during training, but then when we went to
Yeah,
present in
yeah.
in Geneva,
Yeah,
in
I
Switzerland,
think
we didn't take the big sensor with us.
I
Yeah.
think he meant to ask about the training data. I'm not sure, but I just want to avoid any confusion here.
Right.
Because
Yeah,
after the training, you don't need that.
so we used a reference sensor to train the model, but then afterwards, when we actually flew out to present, we didn't use the reference sensor. Yeah.
Thanks, Byron. Okay. What are your math foundations for deep learning?
Okay. So it's ideal if you know calculus, but to be honest, you don't even need to. Like, for a lot of deep learning stuff, you can just use the libraries that I provided to you and sort of treat it as like a black box that you don't really understand. And you can get a lot of work done that way. But if you really want to understand, you do need to know calculus.
Well, as a coach, I have to point it out to actually our team members has really advanced background in math. That's by accident because was a robotics coach. We didn't teach them specifically for those fundamentals, but I think either Byron, Anthony, Ryan, so most of the software leads in our team, they're actually working at the calculus level already. Especially Ryan, he's like 10 rising 10s, but he's on calculus. And especially for those control theories we're teaching them or we're mentoring them, that requires understanding of like the relative equations and the matrix form of representing the state space. And you still need to know a bit of randomized process and the statistics like the probability distributions, those kind of fundamentals you have to know that. But as a coach, I have to say we're lucky to have these talented kids who are self-motivated to involve their math skills already. So we don't have to reteach them.
Thank you, Coach Gu. The next question, what sets your team apart from other robotics teams? Okay, maybe I can answer this question.
Yeah, you want to answer it, Melody?
Yeah. So I think something that might set our team apart from other teams is I think we're really dedicated to every single aspect of robotics. And so what I mean by that is when you join any type of robotics team, there's going to be a lot of components, whether that's, like the software, hardware, CAD, or even something as like scouting. So in FTC, we do scouting, which is where we watch robots and record their scores. And so I think our team is really dedicated to every single process. So even with our scouting, we have our own whole system with that, and it's very detailed and in depth. Same thing with outreach. I think if you get to know some other FTC teams, you'll start to notice that a lot of them do outreach as well. But I think something that our team does that's special is we do really consistent and long-term outreach. So a lot of the programs that we've been working with have been partnerships for several years, and we check in on them weekly. Same thing with a lot of the teams we've mentored. And I think at the end of the day, that's something that makes a difference. Ryan, Byron, do you guys have anything to add?
No, I think the point about dedication is definitely something that's really important. And another thing I think is the teamwork skills that we've learned and that we've picked up from the generations before us. I'm a third generation team member. Melody and Byron are second generation team members. So we have all of this experience in how to properly manage the team and get all the teamwork done. And communication, all these skills that we've mentioned today.
Okay. Based on your experience, which part is more challenging, autonomous or teleop?
So I wouldn't necessarily place one as more difficult than the other. It's for many teams, the autonomous is going to be more challenging because everything has to be autonomously controlled. We use like 14 sensors and control algorithms to control a robot during autonomous. But for our team, because we're trying to always take things to the next level, we're trying to make the teleop as challenging as well by helping out the drivers a lot. So we also have a lot of things going during the teleop section, like the extended Kalman filter that we implement for those very reasons.
Okay. How many times does the team meet together each week?
So right now our team has a schedule where we pretty much meet once a week on Friday, 50 weeks a year. And then on Saturday and Sunday, we will have the team members come in to work on the robot if necessary.
And then during the week as well, everyone maybe working on their own portion or scheduling individual meetings with other team members.
Yeah, so we'll have like sub-team meetings for the outreach team or software team. And as for actual time, for our main team meeting, it usually lasts about 3 to 4 hours. But we dedicate probably around anywhere between 10 to 20 or more hours a week, depending on how close we are to competitions.
Yeah, so maybe closer to Worlds, the few weeks before leading Worlds, our meetings might go a little bit longer, but yeah. Okay. Is TensorFlow what you're using for deep learning?
For FTC, yeah, I'm pretty sure Anthony used TensorFlow, right, Coach Gu?
Yeah, we're actually using the Keras layer to self-compose our own model, but yeah, the deployment layer is still TensorFlow based.
Oh, Keras. Okay, yeah. So we use Keras. But for FTC, that's for FGC, the model we built that I was talking about. For FTC though, if you want to use deep learning, you usually have to use TensorFlow because that's just what you're given.
In robot design, did you have many evolutions or iterations in one season? And what did you do to reduce the number of iterations so we can reach a good design in a short amount of time?
Yeah, so over the previous season, we had probably 4 or 5 main iterations to our robot, but we have a bunch of sub iterations as well. And we follow something called the agile engineering process, where we kind of had like these iterations from meet to meet, and then we have sprint iterations in between as well. And as for how we can reduce the amount of iterations, we try not to reduce the amount of iterations, but rather reduce the amount of time between each iteration. So we can do this by, for example, simulating everything beforehand within our computer-aided design software and making sure that we don't have any conflicts. So when we build the robot, it's immediately all good to go and we don't have any conflicts between parts. And this way we can quickly design a robot, test it in a real world scenario like a tournament, and then improve on it for our next iteration.
Okay. Does anyone else have any more questions? Okay. What kind of simulations? I think they're referring to what Ryan was just.
So I'm not completely familiar with that because that is a hardware team thing and I'm on the software team, but I do know that we run things like static stress analysis in order to make sure that our custom printed parts aren't going to break. And we run things like finite element analysis as well on all of the things, custom parts and the robot itself. And as for the CAD tool, we are using Autodesk Fusion 360.
And I think, Ryan, for software-wise, you did a lot of the mock testing, right? So you actually started your hardware abstraction layer even before the hardware is fully ready, right? That's kind of mocking and simulation, right?
Yeah.
Does anyone else have any other questions? Okay, if you guys want to think about some questions and add them into the chat, I can ask some questions to Ryan and Byron. What do you think within your projects or just on the robotics team in general were some challenges you might have encountered, and how did you work with your team or work to solve those?
Yeah, so one challenge we encountered was definitely just finding an idea in the first place. So we debated for a long time over what to do, because originally all we were given was carbon capture, something to do with carbon and the atmosphere, and that's really open-ended. So we debated for a long time, we searched through all different options, and we talked to a lot of different experts, but before finally settling on this final idea of making a better AI-powered carbon sensor. And so, yeah, just deciding where to go. I think something that was really helpful towards us was setting down some explicit plans. So we first narrowed down which category we wanted it to be in, and then we had individual team members suggest different options, and then of course we went and talked to experts in the field to get a real sense of what problems are. So it's a lot of research beforehand and a lot of cooperation to decide like which direction to go in for like these sort of open-ended projects.
And Ryan, do you want to?
I think for me, the challenges are also kind of pretty similar to what Byron said, where our team is trying to kind of get an idea out in order to build a robot for the season, because the game is pretty vague. It's just put cones on poles. There's a million ways you can put a cone on a pole, and how you actually want to approach that is something that we had to approach at the beginning of the season, and we had to really do a lot of communication between team members and brainstorming in order to get our design out.
What advice do you have for aspiring robotics enthusiasts who want to excel in competitions like the World Championships or the First Global Challenge?
I think kind of along the lines of what I said earlier, is just focusing on learning as many skills as you can, which will really, if you learn a lot of things, then the rewards will come eventually. You will be able to reach levels of competition that you want. Just focus on being a better team member and learning more about all the things that you need to learn, and you will get what you want.
Okay, I can also answer that question. So I think that with robotics and a lot of STEM and technology in general, sometimes the process may not be perfectly linear. And I think being able to kind of bounce back from your setbacks and just keep steady on your progress and keep being dedicated. So I know that a lot of our team members have been doing robotics for a very, very long time. And I think it takes a certain amount of time to reach competitions and awards such as winning worlds. Like a lot of us have done robotics for over 10 years now, and it's taken us a very long amount of time to get there. And kind of also what Ryan said is, as long as you keep learning and keep exploring, and I think keeping a passion for what you're doing, I think you'll end up seeing a lot of progress, and the awards will come as you continue to do that. Byron, do you want to answer that question as well?
Yeah, honestly, I just agree with what you guys said, which is like focus on developing your own skills, focusing on building the best robot and like being the best competitor you can be, instead of looking at the results, and the results will come.
Okay. How do you hold each member accountable, especially the new members?
So yeah, I think some of the coaches can answer this better than I do, but I think something that's very important is being self-motivated. So something we look out for in every new member is like the the type of person that we don't have to try that hard to keep them accountable. And so sure, they may miss a few deadlines, uh they may forget to do a few things, but if we remind them of them, we remind them of that kind of thing, they're able to like take their own responsibility for the mistakes they made and fix themselves instead of like the team itself having to go through a lot of effort to hold them accountable.
Yeah, and I think when you kind of go through the robotics team environment, you'll realize that accountability kind of goes both ways. So if you're meeting all your deadlines and working well with your team members, they'll do the same and respect you. And I think also just on our team, we have a really great kind of mentoring system and pipeline. I know Byron popped up the graphic at the beginning of his presentation, but we have a lot of kind of section leads and mentors in every aspect. And I think that's really beneficial for new members coming in so that they can understand the various processes and systems on our team. Okay. How do you think robotics competitions have contributed to your personal and academic growth and to the college admissions process?
So for me, I definitely think that I've benefited a lot and learned a lot from robotics competitions because you learn, again, so many things. It's not just robotics. On the technical side, you are learning a lot about how to code, about math, about engineering and these kinds of principles. And on the non-technical side, you're learning how to work on a team and communicate with others, both of which are very important skills for the future. And you're also learning all sorts of other things like time management, project management, business, marketing, how you can present your work like we are right now. And as for college admissions, I don't know because I'm only a sophomore, but I think Melody and Byron can elaborate a little more on that.
Byron, do you?
Yeah, basically all the stuff you just said, like stuff that it's a lot of like all the skills you learn, the social skills, the technical skills, all that's very, very important to like personal growth as well as college admissions. I know those were a big part of college. What I will say is please don't do activities just for college. Do activities like robotics because you enjoy them and you find passion for them because it's like if that doesn't happen, you're not gonna do well. If you don't actually like the activity, you're not gonna do well, and then colleges will be able to tell. So
Yeah. And kind of going off of what Byron said, I think that robotics is one of the activities that takes a lot of passion and drive to continue. Sometimes it can be really challenging or tough. So I think all of our members are really passionate about what we do. And I think for me personally, doing robotics for so many years has given me a lot of direction as to what I want to major in and what I want to do even after college. So within the team, I do a lot of kind of business and outreach. And so that has led to, what I want to major in college. And I think I can say that for all of the seniors this year as well, I'm pretty sure everyone is doing something technology or STEM related in college. And that is largely due to the fact that we've been on this robotics team and learned for so many years. Before you selected the innovation topic, did you do research? And in the beginning, did your team have many different ideas, and how did you converge into one idea and kind of think that that was the final and good one? Byron, do you want to answer that one for the innovation project?
yeah, so we did have a lot of different ideas at first. We're all just like throwing out stuff, seeing what's stuck, and really just converging to one idea was a very long process. We debated like the pros and cons of each idea, and like we try to imagine how each of them would work, and we slowly eliminated them until we found the best one, the one that would work for us. Yeah. We did a lot of research beforehand, and as I said, we talked to like the experts and the professors.
And I think the Byron kind of forgot one of the aspects, because as a national team, right, it is also FGC's favor or requirement for each national team. They select as a topic to kind of representing their national like features or aspects. For example, we noticed in our survey, actually Byron led that. So in actually our survey, we noticed like the national team of Greece, right? Because Greece is famous for its like the sightseeing, the tourism, those kind of industry thing. So their hotel industry is quite advanced. So Greece team was actually focusing on how to reduce the carbon footprints in their hotel industry. That's one example. And we also notice like the team of Romania or team of some East Europe countries, they're focusing on how to reduce or capture the carbon footprints in their mining industry. It's all matching their national characterized. So I think Byron captured the United States national characterized really well, because number one, USA is large. We basically have everything. We got big hotels, we got big large carbon footprint, but like Byron captured it accurately, like the entire overall industry and enterprise carbon footprint is one of the USA specialized problem, right? So I think Byron hosted that survey and we eventually captured this, and we decided this is well enough to represent a big USA problem, and the kids of the team USA is confident to address that. That's why Byron can come up with this idea like hold the big enterprises and small enterprise in hold with a large sensor network and even deployed by our drone.
Yeah, thank you, Coach Gu. How do you fund your team, and where could I, if I were to start a team, get funding for that team? So there's various ways to get funding to start first robotics team. So a lot of times we do reach out to companies. So a lot of large tech companies we will reach out to for sponsorships, and kind of going with that sponsorship, we may offer some certain perks with our team. So sometimes we'll offer like a summer camp for the employees of that company in return for a sponsorship to pay for, you know, various aspects of our season. We also do host various types of camps and things like that throughout the summer to do fundraising for our team. Does anyone else have any questions to ask? Okay, then.
Yeah.
Okay.
I think we have all questions, right? Do you mind I say, let me say a couple of words for parents.
Yes.
Yeah, 我就用汉语讲吧哈。那个，我们今天的活动基本上就快结束了。非常感谢王芳教授、古竹教授，还有我们3位同学Byron、Melody and Ryan， 给我们做了非常非常精彩的演讲哈。其实我今天也感触非常深，而我听到了很多的事情，我也想到了很多哈。我们怎么样把每一个孩子给他，我最多听到的呢是，其实我们有几个 words 比方说是刻苦训练，对吧？这个 high priority 还有坚持。然后呢，我们可以看到他们组队有一件事情我特别这个感慨，就是说他们说哦已经是 3 generations， right？ 也许是 first generation， 我知道那个 Samuel 还有那个 Brandon 啊，还有这个Evan Lee 啊，还有一些队员哈，那个是我知道的很老的，一直到现在已经有3代了，所以这个不是偶然的，这个是要有很长的时间来进行提高。 然后我们的孩子能够谈到什么呢？我们孩子谈到的不是什么我考上了什么 Yale 啊，还是我考上了 Berkeley，这些都是水到渠成的事情。他们讨论的呢是 teamwork， 他们讨论的是 passion， 而且呢，他们有非常好的这个科学的研究方法，是吧？我们看他们非常 innovative 的项目。而且呢，他们说他们也告诉说我们怎么样去做这些 survey， 我们怎么样和大学和很多的这个学术专家或者技术专家讨论，这些呢都是我们追求追求卓越的，实际上是我们把它们 put together， 我们可以得到一个 big picture， 就是说为什么我们的队，我们的这个8565，这个叫做technic bots right， 这个队能够取得这样的成绩。所以呢，我最后想说一句话哈，想给大家一个启发，就是说我们不光是要有刻苦的精神，不光有团队精神，还有追求卓越。其实我还看到了另外一个很重要的一件事情，就是说我们的教练还有我们的队员是这个有上帝的祝福，我们有这么好的教练和王放教练，还有古族教练，还有我们今天做这个 presentation 的这么好的这个队员，还有其他的很好的队员，这也都是我们培养孩子，希望孩子追求卓越的这些必要的这个因素。所以我也希望这个活动呢能够给我的学生也有很多的启发，也祝愿我们的这个队继续延续下去，再创辉煌。
好的，感谢孟玉博士给我们这个机会，也感谢我们所有的队员和来倾听的家长和孩子们，就大家都确实非常的 talented， 我很感动。
Yeah, thanks, Dr. Meng, for this great opportunity. I know Byron, Ryan, and I had a great time sharing some of our experiences and some of the projects that we've worked on throughout our years in robotics.
Yeah，谢谢大家。
好，谢谢。那我们说再见了啊。OK， 我们下次再见。
嗯
Yeah， goodbye。
拜拜。
Bye.